In this question, it is given that consider the hyperbola this with foci at S and S1, where S lies on the positive x-axis. Let P be a point on the hyperbola in the first quadrant. Let angle SP-S1 is equal to alpha, where alpha is less than pi by 2. The straight line passing through the point S and having the same slope as that of tangent at P to the hyperbola intersects the straight line S1P at P1. Let delta be the distance of P from the straight line SP1 and beta is equal to S1P. Then the greatest integer less than or equal to beta delta upon 9 into sine alpha by 2 is. One solution of this I have already uploaded. Now I will give you two more solutions. I will say the third solution is the best solution, and that solution contains only two lines. Agreed, that solution cannot be taken as a proper mathematical way, but in any examination where objective questions are there, we are concerned with only answer. Hence, according to this, the third way will be the best way, and that will be containing only two lines. But that way I will tell you in the end of this. First, I am telling you the alternative way of this question. I mean to say, one solution I have already uploaded. This is the second solution. First solution and second solution are proper mathematical ways. Even if third solution cannot be taken as proper mathematical way, but the answer will be surely correct, and we are concerned with only answer. What I mean to say, you will understand when I will do the question by third way. Out of the two proper mathematical ways, the first way was better. Second way I am giving you just for making your concepts more strong. According to the information of question, there is a hyperbola, and from the equation it's clear that it is a horizontal hyperbola. This point will be having x coordinate 10 and this point will be having x coordinate minus 10. And then he says let P is any point on the hyperbola. S is one focus, S1 is second focus. The angle SP S1 is alpha. After that, we draw a tangent at the point P. Then a line is drawn through the point S, which is parallel to the tangent. The length S1P is given by beta, and delta is the distance of P from this, and it is also given that the line S1P is cutting this parallel line at some point P1, and delta is the distance of P from this parallel line, that is this distance is delta. And we know that tangent at any point P to the hyperbola always bisects the angle between SP and S1P. Hence, I can say this angle is sure to be alpha by 2. Therefore, this angle will also be alpha by 2. And our question is to find the value of beta delta by 9 sine alpha by 2. It is clear that if this length is delta, this angle is alpha by 2, then SP will be delta cosec alpha by 2. And now, because this complete angle is alpha, using cosine formula I can say cos alpha is equal to beta square plus delta cosec alpha by 2 square minus the distance s1 square upon 2 beta delta cosec alpha by 2. We know that s1 is 2ae, and we also know that a square e square is equal to a square plus b square. This formula you must be knowing. Hence, I get a square e square is 164. Hence, the value of 2ae will be 2 under root 164. That is 4 under root 41. It is also known to us that S1P minus SP is always equal to 2A. That is, I mean to say S1P minus SP is always equal to 2A. That is 20. Clearly, S1P is beta and SP is delta cosec alpha by 2. This is equal to 20. Actually, I want to find the value of this. Therefore, I am squaring both sides. I will be getting beta square plus delta cosec alpha by 2 whole square minus 2 beta delta cosec alpha by 2 will be equal to 400. That is, I can say beta square plus delta square cosec alpha by 2 square is equal to 400 plus 2 beta delta cosec alpha by 2. And after using this value of this in this expression, everywhere 2 beta delta cosec alpha by 2 will come. And for simplicity, I'll be naming 2 beta delta cosec alpha by 2 by some number, say lambda. And now using the value of this as I have derived, I get cos alpha is equal to 400 plus 2 beta delta cosec alpha by 2 minus s1, which is equal to 2ae, which is equal to this. I get 4 under root 41 square upon 2 beta delta cosec alpha by 2. And in the next step, for simplicity, I will be writing lambda instead of this, because it is a bit lengthy to write this again and again. And I will be getting the result cos alpha is equal to lambda minus the value of this is 656. Therefore, I will be getting now 256 upon lambda, which means lambda into 2 sine square alpha by 2 is equal to 256. And the value of lambda was 2 beta delta cosec alpha by 2 into 2 sine square alpha by 2 is equal to 256. That is, I get beta delta sine alpha by 2 upon 9 is equal to 64 by 9, that is 7 point something. Hence we have got the value of beta delta sine alpha by 2 by 9 as 7 point something. Therefore the greatest integer less than or equal to this becomes 7. Therefore the answer is 7. And now the third way, note that in the question alpha can be any angle, but only condition is alpha is less than pi by 2. That is, it is given that this complete angle is less than pi by 2. And because from the language of the question, it is clear that the value of greatest integer less than or equal to this is going to be a constant. And second condition is alpha is less than pi by 2 is also given. And it is also clear that as I take p further and further, the value of this angle will go on decreasing. And as p comes nearer and nearer, this angle will go on increasing. But it is not difficult for you to see that by taking p nearer or farther, all the steps are going to be same. Even if this angle is more than pi by 2, even then all the steps are going to be same. Therefore, why not take p just here? You may say that if p comes here, then alpha will become pi. Actually, whether you take p anywhere, all the steps are going to be same. He has given this condition alpha less than pi by 2. You should not use the magical method, because if he doesn't give this condition, students will take the case when p is coming at this point, which is a and a dash. But you should be smart enough to see that even if p comes nearer and nearer, even then all the steps are going to be same. You should not fall in the trap of examiner. And if I take the point p here, then it is very easy, because in that case alpha will become 180, beta will become the length s1a. This is equal to 2 under root 41 plus 10, and the value of AE can be found easily, because we know that A square E square is equal to A square plus B square. That is, A square E square is 100 plus 64, that is 164. Therefore AE will become 2 under root 41, that is, I have put the value of beta. And obviously delta will be AS, that is, it will be 2 under root 41 minus 10, because the length from here till here is 241 and the length from here till here is 10. And now putting the values of alpha, beta and delta, 2 under root 41 plus 10 into 2 under root 41 minus 10 into sine 90, that is 1 upon 9. That is, it is equal to 164 minus 100 by 9, that is 64 by 9, that is 7 point something. Hence greatest integer less than or equal to this will become 7.